Hello. Now I'm going to give you notes on the exceptions to the octet rule when drawing Lewis structures. So the octet rule cannot be satisfied if in step 1 you get an odd number or the central atom can have fewer or greater than 8. So we have to do a little bit of math. So let's go ahead and get started. The first two are going to be incomplete octets, which means less than 8. All right, so let's start with NO2. Right, and do everything the same until the end. So nitrogen, 5 valence electrons, oxygen, 2 times 6, so 17 valence electrons. 17 is an odd number, so our central atom is not going to have 8, but that's okay. All right, so nitrogen is our central atom. We have 2 oxygens, covalent bond, subtract 4. 13. So I'm going to go 6 on the oxygens. So I have 1 left. Okay, it's going to go on nitrogen. All right, so because I have an odd number, nitrogen will never have 8, but he can get closer to 8. So right now nitrogen has 2, 4, 5. We can make him have 7, but we don't want to go over it. So one of the oxygens, it doesn't matter which side, is going to donate and double bond with nitrogen. So now nitrogen has 7, but not 8, and that's okay. All right, next one, BH3. All right, boron has 3 valence electrons, oxygen, 3 times 1, so 6 valence electrons. Okay, boron is in the center because hydrogen is never in the center, surrounded by 3 hydrogens. Okay, do your subtraction. We just used 6, and so 6. We are totally out of dots. No more dots anywhere. I can't double bond with hydrogen because he doesn't have any dots. Boron, we're just done. Boron has 6. He's never going to have 8, but this is okay. We cannot make him happy. Okay, so that's incomplete octets, less than 8. All right, now let's do an expanded octet, more than 8. So PCl5. All right, so phosphorus is 5. Chlorine is 5 times 7. So that's 40. Okay, phosphorus is our central atom. And we have 5 chlorines that need to come off of the P. So you will have to kind of do a little diagonal business. 5, 10, 50, or 2, 4, 6, 8, 10. I have 30 left. So 6 on each chlorine. Would give us 30. Okay, we're all out of dots. If you count up phosphorus, 2, 4, 6, 8, 10. I call this super happy. He has more than 8, so he is super happy. And that's totally fine. That's the way it has to be. Okay, expanded octet, more than 8. All right, let's do another one. ClF3. So chlorine is 7. Fluorine is 7 times 3, 21, 28. Chlorine's our central atom. 3 fluorines, minus 6, 22. Okay, make your fluorines happy. So that's 18. Okay, we have 4 left, 4 dots left. According to our steps, they need to go on the central atom. So I'm going to put 2 on the top of chlorine, and then 2 more on one of the diagonals. I know, I said never do diagonals, but this is an exception. So now I placed my extra dots on the central atom, but if you count, 2, 4, 6, 8, 10, chlorine has more than 8, but that's okay. Okay, let's do another one. SF6. Sulfur has 6. Fluorine is 7 times 6, 42, 48, I think. S is in the center. Draw 6 fluorines. 1, 2, 3, 4, 5, 6. Yep, good. 4, 6, 8, 10, 12. There's 36. Okay, 36. By making all the fluorines happy, I just placed 36 dots. I have no more dots. Sulfur is super happy, but that's okay. All right, now we need to go to a polyatomic. Polyatomics we talked about last unit, but what if you have to draw their Lewis structure? All right, so if we have NH4 with a 1 plus, the 1 plus means that we've lost one. So let's do the same. Step 1, nitrogen is 5. Hydrogen is 1 valence electron times 4. So that's 9 valence electrons. But because it has a +1 charge, that means we have to subtract 1. Because that means he lost 1. And now we draw the picture. Nitrogen's in the center. 4 hydrogens. Subtract 8. Get 0. Okay? When you do a polyatomic, your Lewis structure, the final picture, has to be in brackets with the charge on the outside. So for polyatomics, you're either going to add or subtract the charge and then put the Lewis structure in brackets with the charge on the outside. Okay, so let's do phosphate. All right, so phosphate is PO4 with a -3 charge. So phosphorus is 5. Oxygen is 4 times 6. So that's 29. Yeah, I think. -3 means that we gained 3. So then that new total would be 32. Phosphorus is in the center, surrounded by our 4 oxygens. Subtract 8, you get 24. You make all your oxygens happy with 6 more. You've run out of dots. So you have no more dots, but phosphorus is happy. You put them in brackets with the charge on the outside. Okay? Now we gotta get a little bit more complicated. These are multiple central atoms. Multiple central atoms. So we have C2H4. Carbon, 2 times 4. Hydrogen, 4 times 1. 8, 9, 10, 11, 12. Okay, but if you look at the formula, you have 2 carbons and 4 hydrogens. You don't have anything that has a single element to be the central atom. So this is going to have technically 2 central atoms. So the first thing I would do is hook the 2 carbons together. Hydrogens cannot be in the center, so carbons are in the center. Okay, so hook those together. Those are our 2 central atoms that we're going to build around. We have 4 hydrogens, okay? Each central atom likes to if you can, make them evenly distributed. So if you have 4 hydrogens, you're going to put 2 on one carbon and 2 on the other. So there's 2 and then 2. Okay, so 2 central atoms, and you kind of split them up as evenly as you can. So when I subtract 2, 4, 6, 8, 10, okay, I have 2 left. So let's just say that I'm going to make this carbon happy with my 2 dots. So now he's happy, 2, 4, 6, 8. Okay, I've placed all my dots. This carbon is not happy, 2, 4, 6. So here's what you're going to do. The lone pair on the carbon is going to double bond. So if you count, 2, 4, 6, 8, 2, 4, 6, 8. Okay. All right, let's do another one. C2F2, so 2 times 4 plus 2 times 7, 14 plus 8 is 22, I think. 14 plus 8, yeah. Okay, so again, you have 2 carbons and 2 fluorines. Carbon, again, we're going to hook those together first. Those are our central atoms. And then we have 2 fluorines. Remember, they like to be evenly distributed between the 2 carbons. So we're going to do 1 fluorine on the left and 1 one fluorine on the right. And you can make the fluorines go off the bottom, or you can make the fluorines go off the top. It doesn't matter. Okay, when I subtract, 2, 4, 6. Okay, so what is that, 18? No, that's definitely not 18. Oh, golly, 16? Sorry. Okay, so we have 16 dots. Let's make the fluorines happy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I have 4 left. I'm going to take one of my carbons and make him happy. 1, 2, 3, 4. So now this carbon's happy. 2, 4, 6, 8. The other carbon is not happy, so I'm going to take from the carbon. He's the one that's going to share. So we're going to take a pair from the carbon and double bond. The carbon on the left, 2, 4, 6, still is not happy. So we're going to take the other lone pair from carbon and make a triple bond. 2, 4, 6, 8, 2, 4, 6, 8. Okay, let's do the one that says whoa. Says whoa. C2H5OH. You're probably wondering, why didn't they put the hydrogen with the other 5 hydrogens? Because it helps you visualize who's hooked to who. So what you need to kind of think about is OH is hydroxide. That's going to stay together when we go to draw our picture. So it's written out this way to help you visualize it. Okay, so let's do the same math. So 2 times 4 plus 5 times 1 plus 6 plus 1, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so here we go. 2 carbons. Okay, we have 5 hydrogens. Let's start with 5 hydrogens. Evenly distribute those if you can. So here's what you're going to do. We're going to do 3 on one side, 2 on the other. So there's 1, 2, 3, 4, 5. Okay, so those are our 5 hydrogens. Now look at your OH. We have one more spot we can put it. So here's what we're going to do. O, and then H. So your OH needs to be together. That's why they put them together, kept them together in the formula. Okay, now let's do our subtracting. 2, 4, 6, 8, 10, 12, 14, 16. There are 4 left. They can't go on hydrogens, so they have to go on oxygens. 1, 2, 3, 4. Okay, we're all out of dots. Check to make sure everybody's happy. Oxygen, 2, 4, 6, 8. The hydrogen on the left, 2, 4, 6, 8. Or the carbon on the left, sorry. Carbon on the right, 2, 4, 6, 8. Okay, let's do one more. Oh gosh, we still have a lot. We're going to skip the next one. Let's talk about resonance. We're only going to do a couple resonance because I'm already at 13 minutes. Yikes. Okay, so in your notes, go to number 8, resonance. Resonance is a vocab word. All it means is that you can draw multiple Lewis structures for the same formula. Okay, so let's do one. SO2. All right, so let's do the math. So 6 plus 2 times 6, 18, I believe. All right, so sulfur is a central atom with 2 oxygens on either side, minus 4. Okay, so we have 14 left. So we're going to make our oxygens happy. So that's 12, 13, 14. Okay, we have no more dots. Sulfur is not happy yet. He has 6. That means we need to double bond somewhere. Okay, so resonance comes into play if we can double bond the left side or double bond the right side. That's your resonance structure. Okay, so what does that mean? That means in your first picture, you're going to double bond one of the sides. And then in your second picture, you're going to double bond the other side. And they like to have resonance pictures in brackets as well. It's the same Lewis structure, only you're moving the double bond. It's like a mirror image of it. And yes, you have to draw both pictures. Okay, so let's do one more. Let's do the polyatomic, let's do nitrate. Let's do nitrate. So we're skipping in our notes just a little bit. So we're going to do nitrate. So NO3 with a 1 minus charge. Okay, nitrogen is 5 plus 3 times 6, 18, 19, 20, 21, 22, 23. But it's a minus 1, so that means we add 1. Okay, so nitrogen connected to 3 oxygens. Okay, minus 6, 18, 2, 4, 6, 8, 10, 12, 16, 18. All right, we have no more dots. So here's where resonance comes into play. Nitrogen is not happy. If we double bond the left side, he'll be happy. If we double bond the bottom one, he will also be happy. If we only double bond the other side, he will be happy. So this guy has 3 resonance structures, and you have to draw all 3. But it's also a poly, so we got to put them in brackets. Okay, so I'm going to double bond the left side. And then in my next picture, I'm going to double bond the right side. Should have drawn smaller. And then in my third picture, can you see it? Yep. I'm going to double bond the bottom. So resonance, all you're doing is moving the double bond. Yes, you have to draw all possible resonance structures. Okay, that was long.